homework B. And like I said, 1, 2, and 3, you can just put straight into the calculator. So 4, 5, and 6. So let's look at number 6 together, okay? So number 6, I have a 7th root. That means I need 7 in a group in order to come out, okay? So if I have a to the 34th, all right, so that means that's 34 A's. Okay, that number is pretty big, so I'm not going to sit here and draw out 34 A's, which you can. You can absolutely do that, all right? I'm just not going to. So I'm going to show you another way. I'm going to do 34 divided by 7, all right? Because that is my power over root, right? So if I do that, the whole number that I get is 4, right? So then I have, okay. So if I have a to the power over root, okay? All right, well, I put it into the calculator and it told me that 4 is the whole number. So I'm going to put 4 over here. This is the number of groups. That's the number that comes out. Yeah? 4 times 7 gives me what? What's 4 times 7? 28. So then we have to take that out from 34 to see how many we have left over. What's 34 minus 28? 6. And that's my inside number. Okay? So then over here, I'm going to put 7th root for my inside and outside. So A's, I have 4 that come out, right? And then how many A's inside? The 6. Yes? So now let's look at the B's. I have B to the 21st power. Well, then that's B to the 21 over 7, right? Power over root. Do 21 divided by 7, please, and what do you get? Huh? 3? No decimal?
Yes, 3.
Just 3? Okay, well then that means just the 3 comes out. That's it. And then let's look at the C, or C's. So C to the power over root. What's 9 divided by 7? Do you get a nice pretty number? 1 point something? Okay, well then 9 divided by 7. 1, that's my outside number. 1 times 7 gives me 7. And if I subtract, what's 9 minus 7? 2. Okay, so then that's my remainder. That's my inside number. So then that means C, I have 1 that comes out. How many stay in? 2. C squared. So this is my answer. Okay? Questions about this? Does that answer your question? Okay. All right. So let's look at 7 through 9. Here we go. All right, 7, 8, and 9. Please check and let me know if you have any questions. All right. Let's look at 10, 11, and 12. Is that it? You only have 12 problems for this homework? Oh my goodness, only 12 problems. Okay, so let's get started on exponent rules. Up at the top, we're going to start with a rule called a product of a power. Okay? So for this one, what happens is you have A, right? A is your base. And then you have M, which is an exponent connected to that base, times a, which is the same base, right, to the n power. Well, if you have the same base with exponents and they're multiplying, then you have to add the exponents together. That's the rule, okay? So let's take an example. X squared times x cubed. What is that then? What do you do with those exponents? You add them. What's 2 plus 3?
5.
Yeah, so then this is x to the 5th. All right? If they're separated but they're the same base, you just add the exponents. So then what if you had x to the 1/3, 1/8, 1/8 times x to the 4/8. Yeah, x to the 5/8. You just add your exponents together. Okay? And guys, if you don't know how to add, subtract fractions, put it in the calculator. Okay? Anytime you put fractions into the calculator, just make sure you put it in parentheses. So in the calculator, you would just put parentheses 1/8 plus parentheses 4/8. Okay? And then just do math, enter, enter to give me the fraction. All right? All right, so let's take this rule and let's go to our white practice sheet and we'll try some examples here. Excuse me. Oh, excuse me. All right. So let's look at our first example on the white sheet. All right. So if you have just regular numbers, you're just going to multiply those two guys together. Numbers just do what the operation is, okay? So what is 5 times 2? 10. Yeah, so it's 10. Okay, now look at the cubes, guys. Q here and a Q there. They're multiplying, right? So let me see. Q to the, wait a minute, what power is that?
3.
No, the 3 goes with the R. What power does the Q have?
4.
This one on the left, that's the 1, right? Yeah, and then you're right, so when the one on the right is Q to the 1/4, right? What do you do with these two exponents when your base, good. When your bases are multiplying, you add. So 1 plus parentheses 1/4 gives me what? Write this down. Huh? Okay, good. So Q to the 5/4 power. Good job. And then now the R's, guys. R cubed times R to the 1/3. R cubed times R to the 1/3. What is that? What do you do with those exponents? What do you do with those exponents?
Oh, you add them.
You add them. So what is 3 plus 1/3? Huh? 4? Good. 4/3. And there you go. Done. Pretty good, right? All right, let's do the second one. So they could write it with like a little dot showing that it's multiplying, or they could write it with parentheses showing that it's multiplying. Yes.
It's not 4/3.
No.
It's 10/3.
Yeah.
Is it 10 thirds?
Yeah.
9 over 3, 9 plus, oh my gosh, it is 10 thirds. Oh no. No, good. Sorry, I should have double checked it better. All right, so let's look at the next one. It's okay, Sabrina, we were just trying to make sure everyone's paying attention, right? All right, and obviously Tom was. Okay, so let's look at the next one. It's all multiplying. What do we do with the regular numbers? Do we add them? No, you multiply the regular numbers. Good. So 7 times -3 is what?
-21.
Good, -21. Now look at your x's, guys. You have an x with an exponent and another x with an exponent, and they're multiplying. What do we do?
8, 15.
Oh, what'd you say?
8 over 15.
Good. X to the 8 over 15. Perfect. Good. You add the exponents there. Perfect. Thank you. Feel okay with those? All right. Now let's go back to our purple graphic organizer. We wouldn't really call it a foldable, right?
Unless you like fold it
I guess.
and you fold it into 6 pieces.
Yeah, that's so awkward. All right, so let's look at the next one. The power of a power is right below the one that we just did. So now what you're doing is you already have a to the m power, but you're taking that a to the m power to another power, to the n power, okay? So whenever you have parentheses with an exponent, guys, you have to multiply those exponents, all right? Okay, so we multiply now. So if my example, for example, I had x squared. So I already had x squared, but I take that to the third power. Then that's x squared. You got to multiply those exponents together. What's 2 times 3? 6. So x to the 6th power. Okay? All right, so what if I threw fractions into that mix? So I had x to the 1/4 power already. But then I want to take that to the 2/3 power also. Right? Take it to the power. What do you have to do with those exponents? You multiply? Not add. Multiply it. So if you ever have parentheses with an exponent on the outside, it's going to multiply with other exponents. Okay? So what is 1/4 times 2/3? Should have 1/6. Okay? Questions about this? I'm going to go to the white practice sheet, and we're going to try some of these power of a power property. All right, so I have 16 to the 5th power, and then raised to the 1/4 power. Okay.
You get 5/4.
Okay, so then you have 16. Did you multiply the 5 times 1/4 to win?
Yeah.
Perfect. So then you get 16 to the 5/4. Perfect. But since you have all numbers, make sure you put it into the calculator and see if it gives you a nice non-decimal number. Okay? So then top, like this one, in the calculator, you would put 16 to the 5/4 power. Do you get a non-decimal? If you get a decimal, you just leave it the way it is. 32?
32, yeah.
All right, then it's 32. Because you got to simplify it, okay? All right, then let's look at the next one. K to the 1/6 to the 2/5 power. What is that?
115.
K to the 1/15. K to the 1/6 times 2/5. 1/15.
I thought it was like on two different like level things, but it's all in the same thing.
All right.
Whatever it's called.
I see what, yeah, I see what you're saying. Questions about this? I'm glad you understand. All right, so let's look at the next one. Go back to your purple sheet. Oh, sorry. Yeah, of course. So the next one on our purple sheet is power of a product. Well, guys, this one, parentheses with an exponent, right? So here's, you know how I say parentheses with an exponent, you're like multiplying your exponents? You know, I like to call this one Oprah because you have to distribute it, okay? So basically, everything inside the parentheses gets an N power. So that A gets an M power. B gets an M power. Okay? Do you remember that one Oprah show where, no, because you know what? The one right before, it only had A. In this one, it has an A times a B. You see that? The one below. So the one at the bottom left is just A to the M power. And then this one is A times B to the M power. So you remember that one Oprah show where she gave out cars to everyone?
Oh,
You
yeah,
get a
yeah.
car.
Oh, yeah.
You get a car. You get a car.
You get a
So M is Oprah. Parentheses exponent is Oprah. Because look, you get an M power and you get an M power. Okay? So here's my example. If I have xy squared, okay? Then look at that. You get a square, and you get a square. So this is really x squared times y squared. Okay? Yes.
So if you have the parentheses in there, like x to the quarter power, does you put like do you put the power above the quarter?
No, they would just multiply.
Okay.
Like they would just
So
be
you
side by
just do a
side.
quarter times two.
Mm-hmm. So then, okay, let's look at something like this. What if I had 25 x to the third to the 1/2 power?
And then
Yeah, and that's Oprah. Parentheses to the 1/2 power. Well then, you get a 1/2 power, and you get a 1/2 power. Okay? But the numbers actually get the exponents. Don't just multiply, okay? So this 25 is 25 to the 1/2 power, right? And then the x already had a third power, but then we're going to bring 1/2, so they have to multiply. Does that make sense? So try that for me. What is 25 to the 1/2 power? 5. And then what about the x's? What is 3 times 1/2? Because those are the exponents, so I have to just multiply them, right?
Yeah, 1.5.
Which
Three
is?
halves.
Good. 3/2. Perfect. All done. Now we're going to go to our white practice sheet. Okay? So let's try this one. I have x to the 1/4, y to the 5th, and then everything in parentheses to the 2nd power. All right? Parentheses, exponent, this is Oprah. You get a square, and you get a square. Everybody gets a square. So x to the 1/4, I have to multiply them, right? Times 2. And then y to the 5th times 2. So 1/4 times 2 gives me 1/2. So x to the 1/2. 5 times 2 gives me 10. So y to the 10th. Yes?
Yeah.
All right. Let's try the next one. So I see that there is 4 times p squared times q to the 2/3 power. Well, but then now you have all of that to the 1/2 power. So that's Oprah, right? Okay. So then you get a 1/2 power, and you get a 1/2 power, and that one gets a 1/2 power. Just be careful, the number is 4 to the 1/2 power. P squared to the 1/2. What do you do with those exponents?
Multiply.
Multiply. Q to the 2/3 of the 1/2 power, so you multiply those. So you guys try that, please, and tell me what you get. All right, so 4 to the 1/2 power is 2. P to the what? What's 2 times 1/2?
1.
1. Do I have to write the 1? No. What about the Q? 2/3 times 1/2 gives me?
1/3.
Good. And there you go. And then you're done. Good job. All right, so then back to the purple sheet. Let's go back to our graphic organizer. Negative exponents, guys. I love negative exponents. I think these are so fun. Okay? Here's the thing. We never want our exponents to be negative. We always want them to be positive. Okay? Always happy and positive, not negative. Okay? And the thing is, you can make it be positive if it's negative. Alright? So here's what you do. If you have a to the negative m power, right? So this isn't written as a fraction, but if I had to, I would say it's like that, right? So since it's a negative exponent on the top here, bring it down. Just move it to the other side, and then it becomes positive. All right? So what if it looked like this? It was 1 over a to the negative m. So write this one down, because I didn't put this one in your foldable or your graphic organizer. That one is a fraction, and your negative exponent is on the bottom. So how can I turn this negative exponent into positive? Move it to the other side. Since it's negative on the bottom, move it up. And it becomes positive. Does that make sense? You just move it to the other side, and then it becomes a positive exponent. So, if we had x to the negative 2, and then we have y. Okay? As our example. All right. Which one of these has a negative exponent? The x or the y? The x. Okay. So right here, oh no, not like that. There we go. So the x has a negative exponent. All right, in order to make this positive, I need to move it down, right? So, because if I were to write this as a fraction, it would look like that, right? So then that would be x moved down, and now it became a positive exponent. What still just stays on the top? The y, because the y was good. Does that make sense, Dylan? Yeah? All right. So don't let it confuse you if you get fractions as your exponents, okay? So if you have 12 times x to the negative 2/5. Here's my other example. Well, which one of these is the negative exponent? Just the x, right? Okay. So then how do I make this positive? Gotta move it down, right? So then this becomes x to the positive 2/5. Do I need to move that 12 down? No, because the 12 is already positive, so then that 12 can stay. How's that? That's not that bad, right? Just move it to the other side. Okay, so over to the white practice sheet. If I have 25 to the negative 1/2 power, okay, this 25 has a negative exponent. I don't like that. How do I change this? Yeah, good. Then it has to move down, and then it becomes a positive 1/2 power. And Ethan is completely right. If it moves down, there's something on the top. It's got to be 1. Good. And then guys, 25 to the 1/2 power, there are no x's, y's, no variables. Put in the calculator and see if you get a nice pretty number. 5? Because that's the square root of 25, right? So 1/5. Good. You guys are doing an excellent job. Thank you. All right, let's look at the next one. Ooh, this one's already a fraction. Just be careful though. What has the negative exponent?
Yes.
The x only. That 3 is good. Does everyone see that? All right. So I'm still going to draw my fraction bar because, with these, sometimes we have to move them. So then look at this x to the negative 1/3. Where does that have to go? Up. And then it becomes a positive 1/3 power. 3 stays on the bottom because it's already on the bottom and it's positive, right? Positive exponent. Do I need to write the 1 on the top? No, you don't have to, but am I going to mark it wrong if you did? No. All right? Huh?
It's just an implied.
It is an implied 1, yes. Sometimes it's just reassuring for some students to just write the 1, which is fine, okay? All right, questions on this? Okay. All right, then let's go back to the purple organizer, and let's look at something called a quotient of powers. So with this, on the purple,
It's just in a different order.
yeah. So, okay, so back up to the top. So it's on the top right corner. Okay, so with this, you have a to the n power divided by a to the n power. They're the same base, right? Okay, so when you have something like this and they're dividing, you basically subtract. You subtract from the top minus the bottom, okay? So let's write this on the side for us. It's a little sidebar, okay? If you do m minus n, okay, you subtract your exponents from the top, and if that gives you a positive number, all right, then it stays on the top. All right, because it's positive. You don't have to move it, right? However, if you subtract m minus n and say you get a negative number, okay, then put it on the bottom and make it positive. All right, and I'll show you some examples and maybe that'll help. Okay. I'm going to show you the two different situations, okay? So we could have x to the fifth over x cubed, right? You have to subtract from the top down, right? X to the 5 minus 3. What is that? What's 5 minus 3? 2? Positive 2? Okay. So then that's just x squared. Okay? Yep. It's just, that is the top, right? If I just say x squared, because that's x squared over 1. I'm going to show you an example of a negative one.
You do x cubed divided by x 5.
Yeah. X cubed divided by x to the fifth. So, and that's x to the 3 minus 5. Guys, what's 3 minus 5? Negative 2, right? So since that is negative 2, you want to put this on the bottom and make it positive. So it's a negative 2, put it on the bottom, it becomes a positive 2. Does that make sense? All right. I'll show you the technical way and why, but we'll save that for a stinger. All right. I think this just kind of helps when you're dealing with a whole bunch of these steps, when you go to solve the problems. I think this will help you. So what if you had something like this though? What if you had 32 to the 4/5 power divided by 32 to the 1/5 power? What is that? Yeah, subtract. What is 4/5 minus 1/5?
3/5.
3/5. So this is 32 to the 3/5 power. Oh, look at that. All numbers. Put in the calculator, see if you get a nice pretty number. 8? Absolutely. Good job. All right. Questions? Comments? All right. I love this. You guys are actually, you're doing a really great job. Good. All right, then we'll go over to the practice. So over to the practice sheet, the white sheet. Okay, let's look at this first problem. I know it looks like a lot, okay? We'll just take it one thing at a time. First off, I have a fraction bar, so you know what? I'm going to draw a fraction bar because I want to make sure I keep things in the right spot, okay? Now, start with your numbers. Your numbers are just dividing. Don't worry about subtract and all that because that just applies to your exponents, right? What is 20 divided by 25? What does it simplify to? You can divide both of them by 5, right, Ethan? Is that what you're saying? So then what do you get on top and what's on the bottom? Put in the calculator if you also want to see if they simplify. What'd you get?
Right, like 20 divided by 5?
No, 20 divided by 25. And then hit math, enter, enter.
It's 4/5.
Yeah, 4/5. 4/5. Okay, so the numbers are done. Now I'm going to look at each of the variables, right? So I have the x's. All right, let's look at the x's. I have x to the 8th divided by x cubed. What is that?
5.
Good. That's x to the 8 minus 3, right? Which equals 5. It's a positive number, so it stays on top. X to the 5th. Okay? Now, let's look at the y's. Oh, look at the y's there. We have,
Negative 5 halves.
oh, you got negative 5 halves?
Yeah.
Okay, 1/2 minus 5 gives me negative 5 halves.
So I move it to the bottom.
You sure it's negative 5 halves? Try that one again. Put it in the calculator. 1/2 in parentheses minus 5. Yep, you get negative 9 halves. But since that's a negative, where does your y need to go?
To the bottom.
On the bottom, and then what happens to that exponent?
Times 5.
Turns into a positive 9 halves. Okay? So my x's are done, my y's are done, my numbers are done. What's the only thing left over? Z. Wait, is there anything that I can simplify with the z? No. Do I need to move it? No. So you know what? Just bring it over. And there you go. This is your answer. All right? Tom, just write any of this down.
Put the first one down.
Yeah, let's write all of it down. Don't just stare at me. All right. You want to try the next one? What do you notice in the next one? What do you see right off the bat? Yeah, I see all those negative exponents. Guys, let's change all those negative exponents into positives before we start doing anything, okay? All right. I guess we could simplify the numbers. What is 3 divided by 9? 1/3. Okay, so we'll do that. We'll get the numbers out of the way, right? All right, let's see. I have a negative exponent here, right? So that x to the negative 3rd that's on the top, how do I make it positive? Move it to the bottom. Good. So then it comes down to the bottom and then it becomes a positive 3rd power. Yeah? All right, so that one's done. Now, what about this x to the negative 5th power on the bottom? How do I turn that positive? Right? I took care of that one. That one's done. But what about this one on the bottom that's negative?
You move it to the top.
Yeah, move it to the top, and then it becomes positive. That one's done. Now I'm going to go back up to my y's. Oh, I have that one y. Do I need to move it?
I would say at the top.
Yeah, it just stays on the top. That doesn't have a negative exponent, so that one can just stay. Okay. Now down here, oh, look at that y. Down the bottom, I have y to the negative 3/5. It's negative, but I'll make it positive. Move it to the top. 3/5. So it joins that other y, huh? And then what's left over? The z. Do I need to move that z? No. Okay? Extend this line just a little bit. Okay, so now let's simplify this. Right? I'm still going to draw my fraction bar. Right? And then my numbers are still good because I simplified my numbers. Now let's talk about the x's. You don't need two x's. You have to simplify it down. It's what? X squared, good. 5 minus 3. Where does that x squared go? On the top. Now, what about my y's? Look at this, guys. My y's are on the same side. They're multiplying. This is a y to the first times y to the 3/5. What do you do with those exponents when they're multiplying? Add them. Good. That was the first rule that we looked at, right? So y to the first plus the 3/5. What do we get? What's 1 plus 3/5? Put in your calculators. Do it. Move, move, move. Everyone's staring at me.
day3.
Good. So that means since the y's were up on the top, I have y to the 8/5 on the top. Okay, so my y's are done. Now I have my z. I can't do anything else with that z, right? There's nothing else to simplify it with. So just leave it up on the top. And there you go. Now you're done. You can only have one of each type of variable. You can't have two x's or two y's. Okay? You only need one. Are we okay with this? All right, this is a lot of information, I know. All right, so the last one on your purple graphic organizer is powers of a quotient. So here's the thing though, this again, Oprah, why? Because you have parentheses with an exponent on the top, okay? Parentheses with an exponent, I just think Oprah, because you get an m power and you get an m power. All right? Everything on the top gets that exponent, and everything on the bottom gets that exponent. So, I was like, okay, so, he does, he's sweet. All right, so I have x over y, and then all of this to the second power, right? Do it. This is Oprah. Everybody gets a square, right? So we have x squared over y squared. That's it. That's the whole premise behind that. Okay? It's silly, right? Why would I be scared of that one? That would be amazing. Oprah, I hope you are watching this video. But I just hope she doesn't like sue me for using her name, you know?
I got it.
Because that would be the worst. Okay, but what if I had something like this? X over 27 to the 1/3 power.
You still distribute.
Still distribute. Still Oprah. Well, you know, now that you said it like that, now I'm all nervous to say Oprah. But I'm sure she would be very flattered. So then that would be x gets a 1/3 power. And then what? On the bottom, 27 gets a 1/3 power. But on the bottom, guys, that's all numbers. You gotta put it in the calculator, see if you get a nice non-decimal answer on the bottom. What is 27 to the 1/3 power?
It's 3 again.
3. Yeah? Oh, did you put it in parentheses? All right, let's see. 27 to the 1/3 power. You did? Okay. So then this is it. X to the 1/3 over 3. Questions? Comments? All right. Actually, since we have some, all right. So let's look at our white practice sheet. Okay, so this first problem, guys, I'm going to tell you something that'll make your lives a little bit easier in algebra 2, okay? If you see fractions like this, before you do the whole okra to get to the power, right? Simplify your fraction. It'll make the numbers smaller. It'll make everything else that you have to do just a little bit easier, okay? So 4r cubed over 16. Just the numbers.
Quarter.
Yeah. 4 over 16 simplifies down to 1/4. Right? And then just bring over your r cubed, and all of this is to the power of what? 2.
Square.
Squared.
So now the
Now, okra.
R
You get a square.
R5, right?
No. Uh-huh.
Oh.
They all get a square. Right? And you know that 1, you could give 1 a square, but what's 1 times 1? 1. 1 to the 5th power, still 1. 1 to the 100th power, still 1. Right? Okay, so then this is, I'm not going to write the 1, okay? R cubed squared. On the bottom, I have 4 squared. But r cubed squared, what do you do with the 3 and the 2, Ethan? We said it earlier. Multiply it. So then there's r to the 6th. And what is this guy? What's 4 squared?
16.
16. Can I simplify these two? No. So then we are done here. Okay? So now, look at the next fraction. You see those numbers there? The 343 over 27? Put that in your calculator. Tell me if you can simplify it further. 343 divided by 27.
No, you can't.
No, you get the same thing?
Yeah.
All right. Well then, I can't combine these, x to the 5th, y to the 9th. They're totally different terms, right? Okay, so then okra. You get a 1/3, 343. X to the 5th gets a 1/3. 27 gets a 1/3. And y to the 9th gets a 1/3. Do you agree? Yeah, okay. So I have 343 gets a 1/3. X to the 5th gets a 1/3. 27 gets a 1/3. And y to the 9th gets a 1/3. Okay? regular numbers, you need to put it in the calculator and see if it simplifies, right? 343 to the 1/3 power. Guys, what does that give you? Anybody else? Put in the calculator, put in 343 to the 1/3 power. Good. For 7. Now, x to the what? What's 5 times 1/3? 5/3. Good. Now, on the bottom, 27 to the 1/3. What do you get? 3. And then y to the 9th to the 1/3. What's 9 times 1/3? Huh? 9 times 1/3. Well, 9/3 is going to be what?
3.
Yeah? Y cubed. Okay? Ethan, you have it. You just have to make sure you simplify it. Okay?